Data access objects are kind of like the librarians of the software world. So a data access object is there to manage the boundary between what an application knows and what it wants to share or retrieve from other sources in the world. Think of it kind of like, that executive function who needs somebody to go do the research for them. Again, like that librarian. They're an expert in looking up data and finding it and delivering it to you in a very useful way. If you've ever been at a massive library, it can take a half an hour to go find a book, even if you know its lookup number. Where if you ask the librarian, they might be able to immediately walk over and grab it there. I mean, I know when I was in school, I was often lazy and I would just request books because then I could just show up to the front desk and the librarians already pulled them from me. So the habit to break here is often, especially when you're new to programming and in school, you're taught to create these big monolithic programs where there's all this logic and all the flow tends to be together. And so if you want to read data from a file, you have a main program that loops through a file, you read the data, you create something else with it, you put it on a screen, whatever. It's all happens in a single flow. Um, Often, one function is everything you have needed before, but you know if you need to run anything of that, you have to test everything of that. Imagine a huge, massive system where you have, a file coming in with a million lines of code, and you want to take that file and you want to put it in a database. You want to send it to another system. You're going to do some financial trades. You're going to do some spreadsheets. You're going to do all this sort of stuff. Do I really want to have to test all of that at once? Like I may or may not even be able to read that file. I don't want to do all that work until I know I can read the file or access that database or make that request on the internet. And then it becomes very tough to debug all of that at once. So the idea of the data access object is also around reuse. I typically will not just simply read a file or access a database one single time. I want to pull out all the different little pieces and be able to reuse them as needed, and not even in the same application, sometimes across an application. And so a lot of the architectural patterns we're going to look at, and DAO is certainly one of them, is really trying to define the separation of duties between different pieces of the system. In this case, we have these little fish tanks that are separated, and don't see what type of fish it is. It might be betas inside of there, and that's really important with some kind of fish because they'll attack each other. But in software, what we really want is the separation of duties, so that way, the idea, and this comes back to the solid principles, if you've heard about them, is have a component do one thing. And in this case, our one thing is going to be accessing data from an external system. And so the whole idea of a DAO is it's kind of like the traffic cop of transmitting data. It doesn't necessarily say when things happen per se, but it does organize how data gets out of our system and into our system. It's going to most importantly worry about formats. You don't want your core model of your application to have to worry about SQL code or where commas exist in files or XML or whatever web protocol is being used to send data around. I want to have a nice object model where things are inside of my data. And I don't want to have those objects have to worry about how to write those out in the other format, especially if there's a lot of formats, right? I don't need a XML model and a SQL model and a. I want those models to be somewhat seamless, somewhat transparent. So, one of the functions of a DAO is to convert our model into these other representations that are stored externally. Another function, though, is to convert back when we receive data in those other formats. Um, then it needs to go ahead and be translated back into the model objects, and so we can use those within our system in a meaningful and robust way. So the DAO learns how to speak each of these other formats. I mean, in this case, we're talking sign language, semaphore, SQL. Most likely, you're talking about SQL, XML, file formats, all these different things. So by learning to put that in a separate file, what we do is we make our code more resilient to change. If I change the database structure, for example, I don't have to change the core model. I have to retest the whole model. I only have to change that data access object that I create. If I decide I don't want to use that database, I'm going to switch databases, I don't have to change the rest of the system. I just change that data access object. If I say databases are slow and stupid, I'm going to go to a NoSQL database. I'm going to go to an online store. Or I'm just going to use plain files, especially for testing. I can do that by just simply changing which data access object I call. That's where the idea of a factory and other patterns come to play with data access objects to give me that flexibility. A really important aspect that's overlooked in data access objects, though, is the integrity of the model. Who checks whether data is appropriately created? Well, obviously, when you do user interfaces, you want to do checks on users to make sure the data makes sense. You give validation, you give them errors if they don't send it in. But what about data in a database? Can you trust it all the time? If you control a database, then yes, you absolutely can. If you have a shared database that other systems can access, you might want to check that database, especially if it's across companies, across systems. Even, the web, you don't necessarily trust data coming in, and certainly files could be corrupted along the way. And so one of the functions that DAO can do for you is to have a home to be able to check the integrity of the data in that third party before loading it into your model. And then you can have less checks in your model and just know that when you have data in your model, it is correct, it functions properly. If something is missing data or is formatted the wrong way or in the wrong units, you can convert all that and check all that, put it into the system in a way that it won't break down. And so the idea behind a DAO is creating this, again, single purpose solution. And there's going to be many, many of them. It's not one of them for the whole system. I might have a DAO for users and a DAO for products and a DAO for shopping carts and a DAO for all the different things that you might be building in the system. But I can build them using a series of interfaces and implementations that give me a flexible storage data. Because as we said, data might live in more than one place. I can have an interface to say, hey, this is my interface to be able to load in user information. And I might start with a file that loads in user information. Then I might go to a database that loads on user information. And then as I get fancy in my system, I might go to something called LDAP, a directory system that it, keeps permissions as well for what you can access and whatnot. It can be managed by large enterprise security systems. And so you might change over time, or you might just be, have different deployments on different sites. You might not want to use the heavyweight security for your development environment. You might just use something simpler. And the DAO allows us to not only isolate that logic, but swap it out to the one that's needed in that deployment. So as a whole, DAOs, data access objects, are there to separate a clean model from the realities of the dirty external data. They're the one who's cleanse that data coming into the system and properly format the data going out of the system, and allows us to give many different formats for that and be able to swap it out appropriately and call those appropriately depending on where the system's supposed to go. And so it makes our systems much more flexible and extendable than they would be otherwise, as well as just keeping the core of it simple and easy to code.